This split-screen graphic compares two very different realities. On the left, a standard battery system tested in a pristine laboratory at 25 degrees Celsius. On the right, a PuREPower system built for the reality of an Indian summer, where temperatures hit 50 degrees. India's power infrastructure does not behave like a controlled lab. Outages here are highly unpredictable. Instead of scheduled multi-hour load shedding, homes and businesses experience frequent short-burst power cuts lasting 30 to 90 minutes. To survive these sudden cuts and force heavy equipment back on, Indians have historically relied on brute force, the massive, heavily polluting diesel generator. Recently, global supply chains have pushed a modern alternative into the market. Massive manufacturing lines overseas are churning out LFP, or lithium iron phosphate batteries, marketing them as a universal plug-and-play solution for any country. But real-world field data across the subcontinent reveals a major failure rate. LFP batteries, engineered for gentle, temperate climates, are degrading and dying within 12 to 24 months in India. The idea of a universal battery is a myth. The first major test is the surge load. When you turn on an air conditioner or start an industrial motor, it draws a massive, instantaneous spike of power, often 3 to 5 times its normal running current, just to get moving. Look at the left side of this system graphic, detailing LFP cells. The metric that measures power output is the C rating. LFP chemistry is physically limited to a weak, slow energy release, maxing out at a 0.3 to 0.5 continuous C rating. When you hit an LFP battery with heavy surge demands, the cells degrade exponentially. Now look over at the right side of the graphic. PuREPower explicitly chose NMC, nickel manganese cobalt chemistry. Because of its higher power density, NMC easily sustains a continuous 1C output and effortlessly handles massive 3C surges. This diagram shows exactly how that chemical capability translates to a real building. A single PuREPower NMC unit can branch out to instantly start an AC compressor, power a commercial elevator, and run heavy CNC factory machines simultaneously without voltage sag. Because LFP chemically cannot handle heavy startup spikes without destroying its own lifespan, high-density NMC is the only lithium chemistry physically capable of replacing the raw torque of a diesel generator. Watch this digital thermometer display. The second test is pure heat. When you take a 40-degree ambient heat wave and add the internal friction of high-surge battery operation, the internal cell temperature climbs right past 60 degrees Celsius. At those extreme temperatures, LFP cells rapidly decompose. The electrolyte breaks down and the cells begin to swell. The only way to stop it is by wrapping the batteries in highly expensive, incredibly bulky liquid cooling networks. This transparency graphic shows PuREPower's alternative to liquid cooling. They integrate indigenous nanophase change materials, or NPCM, directly alongside the battery modules. Notice the thermal stability framing around the glowing internal structure. During heavy surge events, the NPCM passively absorbs extreme heat spikes by shifting its physical state at the nanoscale. It cools the cells without requiring a single moving part, liquid pump, or extra drop of electricity. Combining high-performance NMC with passive NPCM technology guarantees safety and longevity without the immense footprint of liquid cooling, perfectly fitting India's space-constrained homes and businesses. The third test involves the recharge. Indian batteries must recharge quickly between those frequent power cuts, often relying on the highly variable, fluctuating energy generated by rooftop solar panels. This graph illustrates why that's a problem. LFP chemistry produces a notoriously flat voltage curve. Under load, the cell voltage barely moves. This means the system's brain is essentially blind. It cannot accurately read how full the battery actually is, making it incredibly difficult to manage rapid, erratic charge cycles. Contrast that with NMC. As the graph changes to a sloped voltage curve, you get a rich, graduated signal. The system knows exactly how much energy is inside at any given second, down to the decimal. PuREPower feeds this sloped data directly into their 5th-generation AI battery management system. It constantly predicts cell imbalances and automatically adjusts to safely absorb those sudden surges of erratic solar power. NMC's readable chemistry guarantees that every drop of unpredictable grid and solar power is captured safely. LFP's chemical blindness, on the other hand, inevitably leads to chronic undercharging and premature cell death. Finally, we have to look at this chart tracking lifespan, because the last myth surrounding LFP is that it's cheaper. It might cost less at checkout, but in the heat of the Indian field reality, LFP yields only 200 to 500 cycles. PuREPower's NMC consistently pushes past 3,000. As the chart shifts to true cost per cycle, the economics invert completely. When you factor in the frequent mandatory replacements, an LFP battery actually costs 3 to 6 times more to run than a highly efficient NMC unit. This engineering conclusion is validated globally. The world's top residential storage brands, including Tesla and Enphase, explicitly chose NMC over LFP for their flagship home products because of its superior ability to handle heavy appliance surges. PuREPower ignored the mass-market Chinese LFP trends to do something highly specific: engineer a bespoke energy solution designed strictly for the harsh parameters of the Indian environment. By pairing NMC chemistry with advanced thermal management and AI, PuREPower has engineered the definitive technological assassination of the Indian diesel generator.